Okay, this time I have started a new document and set up a simple potential divider circuit. Um, and we're going to look at how we can do a little bit more interesting analysis than just finding currents and voltages at a fixed voltage. So um, in this case, I have a voltmeter, a voltage source V1. I've connected up my ground. I have two resistances in series um, that I'm calling R1 and R2, and they both haven't set the resistance on them yet. One thing I'm going to do quickly, of course, is with a potential divider, we're usually measuring a voltage out at this particular point um, in between the two resistors. Just to make my output a little bit clearer, I'm actually going to name this net. I'm going to set up a little what we call output port here. So I'm going to select the label net item, which is this little A here. I click there, and I'm going to call this the out. And I'm actually this time going to choose a port type, and I'm going to call it an output. I'm going to place it here and select a wire to connect it. If you hover over the different wires now, you'll see that this whole wire is now called V out. Now, there's actually no real need to do this if you don't want to, but it just makes things a little bit clearer what your intent is. It's a good idea. If this is going to be a printed schematic, if this is a point where we're supposed to be measuring voltage output, it's a good idea to put that in, but it doesn't actually affect the calculations at all as it's drawn. So that's our V out. This voltage up here still has this node up here still has the default name. So I'm going to give that a name like I did last time. And again, I'm going to call that VCC. I'm going to keep it port type none and just click on there so that when we do our report, this voltage is going to be called VCC. Escape. I've already made my ground connection. Now what I'm going to do is change this, is give these resistors some values. So I'm going to click on R1 and I'm going to make this resistance of 120 ohms. Okay. For this second one, what I'm going to do is I'm going to click on it, but I'm not going to set a number here. I am going to start a curly bracket and put an R in, close a curly bracket, and press enter. Okay, so what is this thing here? This is now a parameter. So this is a value in the circuit that I can change with a script or as I'm running a particular simulation. And what I'm going to do in this particular case is I'm going to see how V out changes as this resistance changes here. So in order to do that, I'm again going to do a operating point calculation. So I could come to the simulation and do DC operating point. I'm not going to do it like this because I just want to show you another way of doing it. Another way of doing this simulation is if you click up here, you'll see a little button which does say .op, but it's actually for any what we call SPICE directive. You can also press S to do the same thing here. But if I click on there, it gives me this little text box. And into there, I'm literally just going to write .op, which if you remember from the simulation dialog box that was up here, was what this was called, what this operating point type simulation is called. So if I click OK, you'll see this actually appears, and it's a bit of a weird thing about SPICE. So you don't actually need this whole front end thing to do SPICE calculations. In fact, SPICE is designed to have a text file as an input, which describes all of this in a text file. describes all the connections, and then has a series of commands for what you want to do. Now, they've kind of graphicalized all of this part, but the actual running of the simulation, they've not really created a graphical version of that. Within LTSpice, you actually put the text directives in, and it shows them on here. So .op means run a DC operating point simulation. So if I just run this at the moment, in fact, I can run it, it'll show you. It says it can't find definition of model R. It's saying this R here, we've not given this a value, so we can give it a value. So what we're going to do is step the value of this individual thing, but we could just use it to set a single value. So if I click on Spice directive again, and now I type in .param R equal 240, say, I get this little thing, I can put it here. I could now run the simulation. Oh yeah, because I haven't set the voltage. Sorry. I have to set the voltage first. 5 volts. Run the simulation. It's going to tell us that V out is 3.33 volts. Because we've set this at 120, we've set this at 240. This literally just sets the value of R to be 240. And so we can change this to change the value of this. That's not very useful on its own. More useful is to step this value and see how the voltage changes. So I'm going to delete this line. You do that with the little scissors cut thing. Cut that out. Put in a new command here. And the command we're going to put in is .step. The full stop beforehand, the period beforehand is important. .step param R 100 to 10K 100. So what have I written here? This tells it to step the parameter R, so the value of this resistor, from 100 to 10,000 ohms in steps of 100. Click OK. Now you can put these things anywhere, but I tend to try to put them all in one place so you can see them. It doesn't matter what order they're in. It's kind of a programming language, but it's not like, it doesn't really matter what order things are. It's really just a set of instructions. So if I run the simulation now, what has happened is it's shown as a graph. It's not displaying anything yet. But what it's done is calculated this circuit multiple times for every value of R from 100 to 10,000 steps of 100. Now we can look at what our V out is, and you'll notice as I hover over, I get this thing that looks like a little probe. Okay, so if I clicked on V out there, and what it's going to do is plot the value of V out for all those different resistances. So along the bottom here is the value we stepped, which was the resistor. And on the vertical line here is the voltage at the point of V out. Now we can also plot, for instance, current. We can look, and this is supposed to be a current meter. It's a bit weird looking, but you can click on, say, this resistor or this resistor, find the current. So that's showing us how the current changes with that resistance. And we can use this to kind of analyze a circuit and see how it's going to behave. Now, one quick thing, the default is to put them top and bottom like this. Personally, I kind of think you can't see very much that way. I think it's better if you click on tile windows, you can it is right click and do tile windows vertically, and then it lets you see the two side by side a little bit more clearly. Okay, so that is our simple setup for changing the value of a resistor for for a range of different values. Okay, in the next one we will make this a little bit more kind of interesting by looking at the effect of the effect of some other things for these for some of the sensor circuits we were looking at last time. Okay,